Welcome to Chemistry Simplified. In today's presentation, we're continuing with our series Introduction to Organic Chemistry, and this is part 2. And we'll be looking at the IUPAC names for the first 10 alkanes. IUPAC stands for International Union of Pure and Applied Chemistry, which provide the names for organic compounds. So the first 10 alkanes are like the alphabet for organic chemistry. You cannot understand organic chemistry unless you know by heart or you memorize the name of the first 10 alkanes. So this is very important that you memorize those structures and you can recognize them. So if we have one carbon, so we're going to use the number of carbon atoms to name those compounds. So if we have one carbon, the prefix for that carbon would be meth. And the name for this compound would be methane. In our previous presentation, we said that alkane are named by using the suffix ane. And this is exactly what we have done here. Since this is an alkane, we're using the suffix or ending ane, attaching it to the prefix. That's how we come up with the name methane. Molecular formula for methane is CH4. And the condensed structural formula is the same thing, CH4. If we have two carbons linked together, the prefix for that would be eth, and the name would be ethane. Molecular formula would be C2H6. Condensed structural formula would be CH3 attached to another CH3. So we know that carbons love to form 4 bonds, so that's how we have CH3 bonded to another CH3. In further presentation, we'll explain that in further detail. 3 carbons linked together, the prefix will be prop, thus the name propane. Molecular formula C3H8, and here is the condensed structural formula. 4 carbons, the prefix would be but, so the name butane. Molecular formula C4H10. 5 carbons, the prefix would be pent, like a pentagon. The name pentane. Molecular formula C5H12. 6 carbons linked together, the prefix would be hex. The name would be hexane. Molecular formula C6H14. Here is the condensed structural formula. 7 carbons, the prefix would be hep. The name heptane. Molecular formula C7H16. 8 carbons, prefix ac. Name actane. Molecular formula C8H18. 9 carbons linked together, the prefix would be non. Name nonane. Molecular formula C9H20. Lastly, 10 carbons, the prefix would be dec. The name would be decane. Molecular formula C10H22. As we have already said, you have to memorize the name of these 10 alkanes so that you can recognize them and be able to name them. And from there, you can build on more complex structures. Now, if we know the number of carbon, we can also determine the number of hydrogen that a particular alkane has. How do we do that? There is a formula. So this formula will help us determine the number of hydrogens that a particular alkane should have. This is the formula C subscript N H 2N plus 2, where N represents the number of carbons that is available. For instance, for our first example, propane. We just learned that propane has 3 carbons. So using the formula C3H2 times 3 plus 2, so propane has 8 carbon. So therefore, the formula C3H8. Our last example, octane. We know that octane has 8 carbons. Using the formula, we substitute 8 for the carbon, so we get C8H2 times 8 plus 2. We come up with the formula C8H18. This is the end of our presentation. If you have found it to be useful, remember to like, subscribe, and share, and use the comment section to let us know what you think about it. Thank you and have a great day. Bye bye.